Hi, so my name is Richa. I'm a sustainability consultant at TTW. In case you don't know us, we're a structural, civil, traffic and facade engineering consultancy. We've been really accelerating our knowledge, our interest and our capabilities around sustainable engineering solutions for the last about 2 years, with a particular focus on embodied carbon. I'm currently speaking to you from North Sydney, and I would like to acknowledge the Camaragal people as the traditional owners of this land, and thank elders past and present for taking care of this land. So today I'm going to run through what, in my view, is the role of an engineer in furthering the demand for low carbon concrete, as well as an introduction to how we are using digital engineering and data management at TTW to measure embodied carbon performance of concrete structures, steel and timber as well, but I'll focus on concrete today. And we're also engaging with our clients and design teams, and as well as concrete suppliers, in an effort to remove some specification barriers. Sorry, just there we go. I want to start off with first highlighting the significant challenge for our design teams to understand and measure embodied carbon across the whole life cycle of a building. This challenge is really rooted in barriers that in data availability, a lack of clear guidance or knowledge in this space, inconsistencies in reporting methodologies. These are all barriers we've talked about with MECLA at previous events, so I won't delve into them too far. But we are seeing more and more concrete manufacturers provide us with EPDs, which has been a real driving force. And our clients, the architects that we work with, our consultants and contractors are also starting to really embrace embodied carbon reduction as a new challenge and a critical challenge, and are really upskilling themselves in this space. And as engineers and specifiers of building materials, we hold a lot of really useful data on the material quantities, material properties, structural design parameters that can be really useful in demystifying some of the barriers, and to really understand the opportunities in the use of low carbon concrete. And seeing this opportunity in the information we hold as a company, late last year, TTW developed a web-based carbon reporting tool and a material customization tool. This tool allows us to quickly visualize the upfront embodied carbon in our projects, trap carbon throughout the life cycle of a project, critique and compare designs based on material selection, material specification, and it informs our engineers on the balance between increasing concrete volume, increasing concrete strength or reinforcement rates, and allows them to feed opportunities for carbon reduction back to our clients. And the tool takes data directly from our Revit models, our structural analysis software, so it's really embedded within our workflows, and applies carbon factors to them from our carbon database, and produces visualizations such as this. We get a really detailed and a flexible breakdown of upfront carbon in our projects. And again, it's a really quick feedback loop to our engineers and design teams, and that's really catered to our project workflows. The biggest value that we found in this tool is that its ability to customize material specifications on our projects, select different concrete mixes, and in just a few clicks, see the carbon implications for the whole project. So we can start to collaborate with concrete suppliers from really early stages to find the right low carbon mix for foundations, for columns, for floors, depending on the structural requirements for those elements. And I see this as an example of innovations and designs that really allow a clear focus on material efficiency and effectively specifying low carbon concrete in our projects. I'm going to give you an example of some sorts of conversations we've been having within our teams to go over a case study we've completed on a typical commercial grid. This study has really helped us initiate some discussions around optimizing column grids and reducing material, low embodied carbon design, and some right from the early planning phases of a project. So this study was conducted over a typical office floor plate with varying column grids. The benchmark is a 12:9 grid with the upfront carbon emissions coming from a 40 MPa concrete mix and in the floor elements, and an ADMPA concrete mix in the columns. And these are quite typical for a commercial building. So all three options use the same concrete strengths and mixes. And the only difference that you're seeing in this slide is coming from changing the column grids or changing the way the structure is behaving. So option 1 and 2, we have a varying column grid, a 9x9 and a 6x9. And option 3 has the same column grid as a benchmark, a 12x9 grid, but a different floor area with the introduction of some cantilevers. So the relative reduction in carbon emissions from option 1 and 2 shows that smaller spans and reducing concrete volumes alone can reduce emissions from up to 25 to 30%. A 6x9 grid is quite small, and it does come with spatial planning implications. So something like that would have to be really coordinated from early days. But once you have more columns, they have smaller loads, and those columns also then result in smaller transfer structures and lower concrete volumes. And if you look at option 3, the slab is still spanning the same 9 meters, similar to option 1 and the benchmark, but these are made efficient by adding 3-meter cantilevers either side, again, reducing concrete volumes and embodied carbon. So once we looked at the impact of structural grids and structural systems, we extended this study to investigate the additional benefits of a low carbon concrete specification by considering carbon at both the early design stages and in material procurement. We can achieve up to 40 to 50% reduction in embodied carbon in a typical PT slab. And studies like this have really given us tangible evidence of the value and opportunities in the application of low carbon concrete in structures. And we've been able to present these to our colleagues, and we've seen them spark some different approaches to design and consult from all of our consultants involved in a project. To summarize how this case study can has really informed our kind of approach to design. If we can consider structure alongside architecture from the early planning phases, we can set both cost and carbon into the design brief from the get-go. And if we can find a balance between spatial planning and material savings, by optimizing the structural grid, for example, we can set both cost and carbon savings into the design brief from the early days. Like Joe mentioned earlier, if we can reduce the material, it reduces cost and it also reduces embodied carbon. And if we any further reduction that comes from in embodied carbon from the design development or in the tendering stages in terms of procuring low carbon concrete, and that's just taking your embodied carbon savings a step further. And if you can start showing the consequences of low carbon concrete specifications early on, we as engineers can collaborate with our concrete technicians from the early days and find the right mix for the right part of the structure and feel more confident about specifying mixes based on the required structural performance. And finally, as engineers, we can also actively advocate for low carbon buildings. Just a few weeks ago, TTW made a public commitment to reducing the upfront carbon in our structural designs by 50% by 2030. So over the past year, we've been working on developing a company-wide embodied carbon database. This uses some of the tools I mentioned to you earlier. We want to measure where we are now and be transparent about our emissions. And 2022 has really been a data collection year for us to calculate a TTW average upfront carbon intensity and set a benchmark to measure ourselves against. That's been a real challenge I see kind of industry-wide is we want to set targets, but we aren't exactly sure how to set our benchmarks. But we will be tracking emissions and setting targets across all of our various sectors. We expect some sectors will have more opportunities for reduction than others, but the idea is to take advantage of the data that we hold and find some low-hanging fruit, as they say, to develop targeted reduction strategies. And as you saw earlier, we also created systems to effectively report carbon and visualize carbon. And we're continually working to develop those tools. And yeah, I'm personally quite excited to see where we are at the end of this year. Hopefully we can bring some really useful information back to our design teams and our clients and help define some project-wide benchmarks and emission reductions. That's it for me. I think we're running short of time, so I won't give a quick summary, but hope that was informative and sparked some new thoughts. But yeah, happy to answer any questions now or later. Pass back to Evan.